Welcome, this is Professor Ridge and today's lesson 5.8, Modeling Using Variation. Our first learning objective is solve direct variation problems. Okay, what is direct variation? So direct variation, if x and y are related by an equation of the form y equals kx to the n power, then we say the relationship is direct variation. And y varies directly with or is proportional to the nth power of x. In direct variation relationships, there is a non-zero constant k, which equals y over x to the n. So basically just solving it for k, right? Divide both sides by x to the n, where k is called the constant of variation, which helps define the relationship between the variables. Okay, how to. Given a description of a direct variation problem, solve for an unknown. Identify the input x and the output y. Determine the constant of variation. You may need to divide y by the specified power of x to determine the constant of variation. Use the constant of variation to write an equation for the relationship. Substitute known values into the equation to find the unknown. All right, let's look at an example. Example 1, solving a direct variation problem. The quantity y varies directly, so that's the key word. So typically in these word problems, they'll tell you that, they'll say y varies directly with the cube of x. Okay. So this is how we're going to set up our model. So it's a varies directly. So let's go back. So this is the equation, the model for direct variation. Y varies directly as the cube of x. So we're going to put x cubed here. So it'll be y equals kx. So we immediately translate that. X to the third. Now, typically, these problems are going to involve two parts. First, you got to figure out what k is, the constant of variation. So we're going to plug in the either an observed value or a given value for an x and y that go together. So here they tell you that y is 25 when x is 2. So you plug in those two values. Then we're going to solve this for k. So now we see 2 cubed is 8, so we got 8k. And then we divide by the 8 to get k by itself. So k is, you can leave it as a fraction, or if you want to use a calculator and get a decimal, that's fine too. Okay, so I don't think I've ever showed you the, on Desmos.com, they have just a scientific calculator if you don't want to do the full graphing calculator. It works. It's basically the same, just without showing you a graph or anything. So if you're just doing calculations, this is a nice little tool. So anyway, so like I was saying, you can leave it as a fraction, or if you want to make it a decimal, you can write it as a decimal. Either way, that's up to you. So let me move that. So then now, once you have k, then you go back to the original model and plug the k in. So it's 3.125 x to the third. So this is our equation of variation. Okay, once we know what k is. And now the second part is we can answer, okay, what's y when x equals 6? So we're going to just plug in the 6 for x. And then get out our calculator and type that in. So let's see here. Okay, I'm just going to leave the 25/8 times 6 cubed. And I get 675. So y is 675 when x is 6. Learning objective 2, solve inverse variation problems. Okay, inverse variation. If x and y are related by an equation of the form y equals k divided by x to the n, where k is a non-zero constant, we say y varies inversely. Okay, so remember, with the nth power of x. So direct variation is you multiply k times x to the n, and then inverse you're going to do divided by. So k divided by x to the n. In inversely proportional relationships or inverse variations, there is a constant multiple k, which equals, now again, if you want to solve this for k, you're going to multiply both sides by x to the n, and you'll get this equation. Okay, k is equal to x to the n y. All right, let's look at example 2 here. Writing a formula for an inversely proportional relationship. A tourist plans to drive 100 miles. Find a formula for the trip. Find a formula for the time the trip will take as a function of the speed of the tourist drives. Okay, so find a formula. A tourist plans to drive 100 miles. Okay, so we know that distance is equal to rate times time. So the distance is going to be the 100. It's basically going to be our k. So k is going to be 100. And if we want to find a formula for time, so we want time all by itself, so we're going to divide by the r. So we get time, or distance is going to be 100. That's going to be our k. And then over r. So this is an inverse variation problem like this. So as r gets bigger, t will get smaller. As r gets smaller, t will get bigger, right? So that they're inversely proportional. Okay, how to. Given a description of an indirect variation problem, solve for an unknown. So your first step, identify your input x, output y. Determine the constant of variation, so you got to solve it for k. You may need to multiply y by the specified power x to determine the constant variation. Basically, I don't think of it that way. I just solve the equation. I'll show you again. Use the constant variation, write the equation, right? So this is going to what I call my step 2. So step 1 is figure out k, so you can write the equation of variation. And then step 2, once you have the equation of variation, you can answer the question, right? Substitute the known values in the equation, find unknown. Okay, so let me show you what I mean here. So example 3, a quantity y varies inversely with the cube of x. So varies inversely, so we got to think the model we're using varies inversely is y equals k divided by, in this case, the cube of x, so be x cubed. Okay, so this is the variation model that we're using. So it's an inverse variation. Our first step is we're going to figure out our constant of variation. All right, so we're going to plug in the 25 and the 2. So 25 for y. 2 for x. Oh, why did I put 2 there for k? That should be k over 2 cubed. So 2 cubed is 8. And now I'm going to solve it for k. So I'm going to multiply both sides by 8. So k is equal to 8 times 25 is 200. So now I'm going to use the constant variation and write the relationship. So this is what I call step 2. Now okay, so I'm going to take k, basically, I think of this as 2 steps, right? Step 1, figure out, let me write this down too. Step 1, figure out what model to use. Plug in your observed value to solve for k. once you know what k is, write the equation of variation. So y equals 200 over x cubed. And now I can answer the question, what's y when x is 6? So y equals 200 over 6 cubed. And then I punch that in my calculator. You get that Desmos one again. So let's see. We got 200 divided by 6 to the third. And that is 0.925. If you want to see it as a fraction, it's 25/7. So whichever way. So if you're not great at fractions, learn how to use this fraction button. So 25/7. How does the book have the answer? They have it as the fraction, 25/7. 25/27. And on to our last learning objective, solve problems involving joint variation. Joint variation occurs when a variable varies directly or inversely with multiple variables. For instance, if x varies directly with both y and z, we have x equals kyz. So it's basically just if it's varies directly with both y and z, you just multiply them. And if x varies directly with y and inversely with z, we have x equals ky. So directly is multiplying and inversely is dividing. Notice that we only use one constant in a joint variation equation. So just 1k, constant variation. All right, let's look at an example. Solving problems involving joint variation. A quantity x varies directly with the square of y and inversely with the cube of z. If x equals 6 when y equals 2 and z equals 8, find x when y equals 1 and z equals 2. So think of it, it's going to have basically the same structure as the other two, the example 1 and example 3, where I think of it as the two steps. First, write down the model that we're describing, the variation. So x varies directly. X varies directly, so that's multiply. Varies directly with the square of y. So that's y squared. And inversely, so that's divided by the cube root of z. So the cube root of z. So this is the model that we're using for this variation problem. And then again, for the first part, we got to figure out what k is. So we need an observed value for all the variables. We need x, y, and z that go together, which they give us. X is 6. Y is 2. And z is 8. So we simplify this, so that's going to be 4. And cube root of 8 is 2. 4 divided by 2 is 4 divided by 2 is 2. And then divide both sides by 2. So k is 3. So once you have k, right, now we can go to the second part of this problem is we can answer the question, what's x? Find x when y is 1 and z is 27. So what we do is we're going to plug this into the model that we started with. So now I'm going to plug it into x equals 3 times y squared over the cube root of z. And now I can answer the question, what's x when y is 1 and z is 27. Cube root of 27 is 3. 1 squared is 1. 3 divided by 3 equals 1. Okay, so you get 1. Okay, that's the end of that section. That was a really short section, which is kind of nice. The last couple have been a little bit long. All right, so you know the drill, right? Practice, practice, practice. Do all those odd exercises at the end of the section. And if you can, do some of the even ones as well. But, you know, at least do all the odds. All right, talk to you later. Have a great night.